The magnetic force acting per unit area. So you can assume now, let the field here, let it be out of the plane. The field here, let it be into the plane. Anything you can assume. So now what we are calculating, the force of interaction between the planes. There's nothing but asking force per unit area of each plane. Earlier we did for wire, no? Now force of interaction for each plane it is. Now let it be lambda current per unit width, let it be lambda. We'll assume, or J, anything you can assume. So let me assume lambda is the current per unit width. Let me assume this. Out of the plane. So what is the field produced by this? The field produced by this will be here. Call B1. This will be B1. And it will also produce B1 here, everywhere, no? By superposition. Similarly, the field produced by this B2 B2. So this will be B2. Here it will be B2. So take help of the superposition condition like this. Now force of interaction between them is asking. So what is the method like? Usually we'll go for these are the plates, no? If you go for three-dimensional. So we'll assume here now a surface. Then we'll calculate the force acting on that given surface here. So the surface is what? Let me take it out. I'll show it after this one. See, any method, I'm just showing this one. Any any directly you can also write this one. So this is the B2. It is produced here. The direction of B2 like this. Keep in mind now. So shall we assume that the plate, this is the plate 1, plate 2. Let's assume that the plate 2 is present in the field of plate 1. And this is a method what will take it. So let this be X. Let this be distance Y. Will it enclose any current? Yes, it is. Okay, directly go for. So main field due to one plate. So what should be the value of B1? So what I'm assuming, the second plate is present in the field of first plate. So what is the value of B1? B1 should be equal to mu naught lambda by 2. The field produced by the plate 1 nearby the plate 2. Mu naught lambda by 2. As they are large plates, consists of different. So as it will be uniform, no? Already I think we have discussed enough of all this one. So this is a B1. So let's, any current will flow in this. So some DI current will flow here, no? DI to you, write it. That current will experience force due to B1. So again, come take help of Fleming's left-hand rule. B1, B1. So in what direction that force should be? That force is going to be in this direction, DF. Similarly, you can analyze here also. I'll show for one. Similarly, for this also you can show it. So this is a DF. So what is a DF? Force acting on that green color shaded strip. DF should be equal to B1 into DI2. What is the length of that? Will be X. What is DI2? DI2 can write as lambda into Y. Lambda. Similarly, what is value of B2? B2 equal to mu naught lambda by 2. So lambda what you can write? 2B2 by mu naught. Correct? No, I did.
Sir, towards the left side, it should be upward, no, sir. B1.
B1, see like a current is flowing, so use right hand thumb rule. So B1 everywhere here should be towards downward, no? Of plate 1, of the plate 2 what happened? There's a wire, no? If a current I flows here.
Yes, sir. Yes, sorry, sir.
Yeah, okay. That one. Okay, this will be the value of like a 2B1 B2 by mu naught into, so this will be XY will come. Is asking that force per unit width. Magnetic induction is how much he has given? Magnetic induction, the value is given B square, the value is B1 equal to B2, no? So this should be later, I'll write it. In then we'll write it, we'll get confused. Plates are identical. So the force per unit width, how much we can write it now? So dF by xy should be equal to 2b square by mu naught. Oh, one more thing. The total magnetic field is given B. I think I'll just change it. The total magnetic field is given B1 plus B2. Let me call this is B dash. So this will become B dash plus B dash. I think try to read question. Some data is given. Induction B between the plates producing. The total field is B. The net field is B. What is that B? B1 plus B2. And in turn, what is B1, B2? They're equal. So therefore, this will become, I think I'll replace B1, B2. Let it be. And I'll come to this one. So this should be 2B dash. So from the formula, df by xy should be equal to 2b dash square by mu naught. 2 mu naught. B dash is what? B by 2 whole square. So this will become B square by 2 mu naught. Now try to see the data given. The net field between the plates is given, not the field produced by individual plates. Try to be careful here now. So not only magnetic pressure. So what we can do is like a the field produced by one surface on other surface will exert a force. I think this is very important. It's there one problem is there in Singage in subjective. Please do go through that. It's very important that one. If a current carrying structure kept in a magnetic field will experience a force. That force per unit area is what? Magnetic pressure. Now you have quite good applications. How do this force will be? Repulsive force shall we put here? So when two plates carry current in opposite direction, So how the force will be? The force per unit area will act in opposite direction. If the current flowing in both the sheets in same direction, it will be attractive. What we did for wire, for even plates also, it can be asked. Okay, getting this one. So there's a plate 1, there's a plate 2. For application, these are very important. So always try to see that the resultant field is given. So therefore, I have to take this one. So this is very important. Please do notice here. Okay, now we'll